Hello friends, in this video I'd like to solve the following problem from the Concrete Mathematics textbook. It's problem number 33 from the 6th chapter. So we wish to prove that the following infinite sum 0.1, 0 plus 0.01, 0.002, 0.0003 and so on converges to a rational number. So because it's not obvious, because infinite sum of rational numbers can in fact converge also to an irrational number. So it's not obvious straight away. Okay. My hints for this problem: this sequence 1, 1, 2, 3, 5, 8, 13, 21 and so on should look familiar to you. And also, this sequence has a well-known explicit closed explicit formula. And then the last fact to be used is that the series of q to the power of k equals 1 over 1 minus q if this quotient is between -1 and 1. It's a well-known formula for the sum of geometric progression. So give it a try and see you in a moment. Okay, so I hope that you managed to solve it. As I suggested, first let's take this sum 0.1 plus 0.001 plus 0.002, 0.0005 and so on. And the crucial observation that these numbers 1, 1, 2, sorry, there should be 3, 3 and so on, these are the consecutive terms of Fibonacci sequence. Yes, so 1, 1, 2, 3, 5, 8, 13, 21 and so on, it's the Fibonacci sequence. It's Fibonacci sequence, and our sum, so maybe let's denote our sum by some letter. I don't know, maybe capital S would be nice. So our sum is just the sum from k equals 1 to infinity of the kth Fibonacci term, the kth term of Fibonacci sequence, over 10 to the power of k. So let's verify it. So for k equals 1, we have 1 over 10, it's 0.1. For k equals 2, the second term of Fibonacci sequence is also 1, so we have 1 over 100, so it's good. Then we would have, for k equals 3, we will have 2 over 10 to the third power, so it's 0.002 and so on. Okay, now the crucial part. There is so-called Binet's formula, which says that the nth term of Fibonacci sequence is 1 plus the square root of 5 over 2 to the nth power minus 1 minus the square root of 5 over 2 to the nth power, all divided by the square root of 5. It's a well-known closed form for Fibonacci sequence. And this also works for n equals 0. It is convenient to extend our sum to the 0th term. It's legal because f0 is 0, so we are adding a 0 to our sum, so it doesn't change. And in fact, we can write our sum in the following manner. Okay, very nice. And now let's split our series in two different series. So we will have sum k goes from 0 to infinity. 1 plus square root of 5, 2 times 10 is 20 to the power of k, minus 1 over square root of 5, and our series from 0 to infinity, 1 minus square root of 5 over 20 to the power of k. Okay, nice. And now let's notice that these numbers here, this number is strictly between 0 and 1, and this number is strictly between -1 and 0. So we know that both of these sums converge, and we can use the formula for geometric series. So it's this number, and here we have 1 over 1 minus the quotient. And here we have the same, 1 over 1 minus the quotient. Very well. And now it's just the matter of simplification. So we are dealing with numbers, rational and irrational numbers. So we have 1 over square root of 5, 20, 19 minus square root of 5, 1 over square root of 5, 20, 19 plus square root of 5. Okay. What now? Now we can take this first fraction and multiply by the conjugate of our number. So we will have 19 squared minus 5. And here we have 1 over square root of 5. 20, 19 minus square root of 5. 19 squared minus 5. Now comes the hard part, crunching the numbers. Crunching the numbers. I will use calculator because I don't want to make mistake. So wait for a minute. Okay, so 19 squared minus 5 is 356. And in the numerator, we will have 380 plus 20 times square root of 5 minus 1 over square root of 5, 356, 380 minus 20 square root of 5. Now, 380 minus 380 disappears. So we have 20 square root of 5 plus 20 square root of 5. So it's 40 square root of 5 over 356. And that's after simplification, after division by 4, it's 10 over 89. 10 over 89. And that is definitely a rational number. This number is most definitely rational. And that, to be honest, concludes our proof, because we have demonstrated that our number is rational, and moreover, we know the exact result. So our sum converges to 10 over 89. And that closes my video. So thank you for watching and see you next time.